Okay, welcome. Myself is Dr. Ashoke De. I am currently working in the Department of Aerospace Engineering as Associate Professor at IIT Kanpur. And what I am going to teach about the finite volume methods. And the finite volume methods, just to give you a brief introduction, the finite volume method is commonly known as one of the widely used CFD tool. CFD means the computational fluid dynamics tool, and this is widely accepted not only in the academic community, it is also accepted in the industry. The reason being that CFD now, with the advancement of the computer, CFD has emerged as an alternative tool to the experiments. It is cost effective, also you can get the solution in very quick turnaround time, because sometimes also the experiments cannot provide you the information every locations or inside the flow domain. So, that makes it very difficult to analyze a complicated system or rather realistic problem. In that sense, CFD has become the very effective tool which can get you the solution in quick fashion. Now, there are different kind of CFD methods. One is very commonly known, which is finite difference method, then finite volume method and the finite element method. But in this particular course, we will be talking about the finite volume method, because each of these different techniques, they have their different way of doing the things. So, essentially we only talking about, we will be talking about the finite volume method. Now, in this particular course, so as you see what CFD does, you have a practical problem of interest which you are interested in. That could be a realistic problem like flow over your automobile vehicle for drag reduction, flow around your aircraft vehicle. So, it could be multiple things, or flow through your air ventilations or the AC duct. So, there are plenty of problems which are of practical interest, and to look at the problems in details, the measurements are not possible. So, in that sense CFD is applied, and what it does, when you have a practical problem of interest, you first try to identify what are the constitutive relations or the governing equations that govern that particular problem. So, the physical problem, either fluid flow problem or heat transfer problem, then you figure out the set of governing equations. Now, once you get the set of governing equations, these are essentially the partial differential equation. So, these partial differential equations actually provide the solution for that practical problem. And how? Now, this representative partial differential equations now needs to be converted to the linear system, and this process, when the PDEs or the governing equations, they are transformed to the linear system, in between you apply your numerical technique. That is, for this particular context of this lecture is the finite volume method. So, you apply your finite volume method, and that set of governing equations is transformed to the linear system. Now, you apply your linear solver. Essentially, the linear system, one has to know the properties and find out the solution to the linear system. Once you find out the linear system, that becomes the representative of the solution to the physical problem. So, that is what essentially CFD does, and as you can see that when you are converting your governing equation to the linear system, your numerical technique comes into the picture, and that is very much particular technique, that is finite volume method, and this method we are going to talk about in this lecture series. And finite volume method, just to note you, this is again, as I said, it is widely accepted not only in academic community, it is in the industry, because this has become a sort of a design tool for most of the industry. Now, finite volume method essentially covers lot of topic, and this will actually, in this particular class or the course, it will be divided into two parts. One is the part 1, which is introduction to finite volume methods 1, and then introduction to finite volume methods 2. But if you look at the complete syllabus, then you see this is the complete syllabus that you have for the finite volume method, which includes your part 1 and part 2. What we start with all the governing equations, that is the transport equation or general scalar transport equation, and the classification of PDEs. That means you talk about all these governing equations which will represent the particular physical problem, and you then understand the general transport equations and also the classification. Then when you move along the process, so that is where it becomes discretization processes. Discretization process means your set of governing equations is now getting transferred through this discretization process to the linear system, and there you come across different things like mesh terminology, types, solution discretization equations. Now once you discretize the system, you have accuracy, consistency, stability, convergence. So these are the things we will talk about. Once that is done, that means you have a set of technique which actually kind of confirm this discretization process. Then we move to the simple system of 2D steady and unsteady diffusion problem. So first we will look at the diffusion problem, and we will talk about all other associated things which will be kind of associated with the diffusion problems like errors, stability, orthogonal, non-orthogonal system, gradient calculations. So once one understands the diffusion system, actually after discretization of the diffusion system, it will lead to a linear system. So one has to understand the linear solver. So in this portion of the topic, we will talk about all the linear solver. That means either direct solver or iterative solvers. Then we talk about different data structure, tridiagonal matrix solver, all other associated different solvers including multi-grid method. So that actually sets you for solution of the linear system. Once that is done, then we will complicate the system and move one step further, talk about the 2D convection diffusion problem. In that case also we talk about steady, unsteady, we talk about different boundary conditions, we talk about orthogonality, non-orthogonality, then accuracy and higher order scheme. Now this becomes very important when you talk about the convection diffusion problem. Having said that, then one is ready for moving ahead and look at the fluid flow problem. Now fluid flow problem will be governed by pretty much Navier-Stokes system, which is a mixed partial differential equation, and it is complicated because now you have pressure gradient term sitting there. There you talk about boundary condition, different solution method, then different pressure velocity coupling, and this is a particular method where we will be talking in primitive variables, that means pressure, velocity, density, like that. And finally towards the end we will talk about some advanced topic like turbulence modeling, boundary conditions and certain things. So that is essentially the total lecture content of finite volume method. Now for this particular part of these things, this is divided into two parts. One is the finite volume 1, which will be the content of this first part, and there we will talk about introduction, we talk about the discretization technique, mesh topology and accuracy, then we end at the 2D diffusion system. So the first part will tell you about all your initial governing equation, discretizations and the 2D diffusion. Now in the follow up semester, the second part would be taught, which will talk about or start with the linear solver, the direct and iterative solver, convection diffusion problem and discretization of the governing equation for the fluid flow problem, and finally these advanced topics. So at the end of these two lecture series, that finite volume 1 and finite volume 2, one should be able to understand clearly what finite volume method is, and he should be able to program on his own to solve simple problems, and then further the knowledge can be extended for the practical complicated problem. Now for getting into finite volume 2, one of the primary prerequisite would be the finite volume 1. As you can see, this whole content has been divided into two equal parts. One cannot do the course finite volume 2 without having a knowledge of finite volume 1, because when you talk about lot of things in the diffusion system, you may skip those things in the finite volume 2 part. Now the suggested textbook, the one of the very classical and phenomenological book is the Patankar, which talk about the finite volume method, and one can look at this book as a reference book. Another book which would be very good is the Farjigar book. This could be also reference book, but this book 4th and 5th, these are could be the, so 1, 4 and 5, this could be sort of textbook, and one can see the, because the material which will be covered, this would be from all these 3 books, and other books are for your reference. So, one can look at these books and get the complete course material. So, as you see that the total course has been divided into 2 equal parts, one is part 1 and is part 2, and the first part will be talking about the first portion starting from the Gaon equation to the diffusion problem, and the follow up lectures in the second part or the follow up semester, this would be part 2, where you start from the linear solver to the fluid flow problem, and this is what we will be doing in the complete finite volume series in part 1 and part 2. Thank you.